Hi, my name is Salman Aziz. Have you ever wondered what observables really are? Are they like promises? Are they like events? Are they sync or are they async? What this hot stream and cold stream does really mean? So if you have a wonder about these concepts, just stay tuned with me and I can assure you that once the end of this video, you will get all these concepts in a much clearer way. So let's start. So over here I have cloned the RXJS repository, and the current version which I'm using, as you can see it over here, it's version 7.001 alpha 1. So if you're using a different version, you will face a different documentation. So now we have just opened the observable MD file and we are going through the observable definition, how RxJS library describes it. So now basically what they are saying, observables are lazy push collections. I don't want to read it out. I want to explain you in a most simplest possible way how to do it, and I feel the best way to do it is in the form of stories. So let us try to go through all of these things in the form of stories. So now what they're just saying, just to get you a bit concept, they're saying there are two types of system: pull-based system, push-based system, and they're saying push-based systems are like promises or observable, and pull-based systems are like function or iterator. What does that really mean? It's really important to understand this concept. Once you get this concept, you will understand observable in way better way than most experts even. So let's start. So once upon a time, there was a customer. He asked developers to build a solution, and they build a solution and they develop some charts or data, category 1 data, category 2 data, let's say, and customers was quite happy. Now the customer wanted a C3 data to be displayed, and for example here they communicated the developers who built the C1 and C2, and the developers said the C3 data that you want is a bit more complicated. We might not be able to do it. We may have to contact the third-party library author to do the solution. Customer said, we don't care, just implement a solution. We want the data here regardless how you do it. Developers sat down together and said, okay, we are displaying C1 data, we are displaying C2 data, we just have to display the C3 data, and we know a third-party author who do this operation. We will just contact them. So now the important concept, the really important concept, is consumer and producer. Now the developers are consumer and the producer is the third-party author. C means, so the C means consumer and P means producer. Third-party author is the producer. Producer is something who produces things. Consumer is the something who consumes things. Quite easy, but it's really important, and you will see why it's important. The developer said, okay, they contacted the third-party author, and he said, okay, that's easy. We have just install it through npm, and we have a function called do work. You just call this function out, and you will get your results. So they said that's quite easy. We will just implement this solution. We will call this function from here and we will implement the solution. They quickly implemented the solution. They gone to prod, and after a while they face an angry customer. Customer was quite angry. What you guys have done? Now all I see is a waiting loading bar in all three of them. What you guys have done, just solve it out, else you're just gonna lose the customer. Developers got really worried because customer is money and this is the only customer they got, so it's high stakes for them. So they quickly sat down together, investigated the issue, and they quickly find out the cause of the issue is they are doing this operation over here. It's making some database call in between, doing heavy computation, and it's taking 30 minutes of time. And once it's taking 30 minutes of time, it has to wait 30 minutes over here as well. And since JavaScript is single threaded, it's all sequential, and it was implemented using a pull-based system. Pull-based system, what is pull-based system? They were just calling this function out and it was executing. So once it was executing this process, it was taking 30 minutes. It took 30 minutes. The second C1 and C2 never get the chance to get evaluated. So all the result was the loading bars start displaying. Developers wanted to find a good solution for that. One of the developers said, why don't you implement an event-based system? Everybody knew what event-based system was. It was basically producer just emitting some values over time. The developers of the third-party author library said, no, it's not possible because we are on cloud and we have to pay how much processor we use. And as you can see it over here, we keep on emitting regardless the consumer exists or not exists, that has cost us a lot of money. So this solution won't work for us. So the event-based solution will not work in this scenario. So another developer, a more smarter developer said, why don't we implement a push-based system? Now that seems interesting. Other developer said, what that means, what is the push-based system? He said, okay, you're calling this function do work and it's doing its work. So instead of calling it in a pull-based way, just call it in a push-based way. Push-based way means you pass us two functions, and like promises, you will pass us resolve and reject. And once we will do the processing, the third-party author will do the processing. Once it's done, it will call resolve. If there is an error, they will call reject. And as soon as that happens, you will get the results over here. So what that means, you don't have to wait for 30 minutes. If you don't have to wait, the C1 and C2 can compute and get the results out of it, while C3 may still have to wait because it's 30 minutes time. The process itself is taking 30 minutes time, so we can't do anything, but the issue of C1 and C2 is solved. So they quickly go into production, they implemented the solution. Customer was now okay, he was okay. He said, okay, now I can wait for 30 minutes for C3. All good, they go into production. So the push-based system solved the problem, but nothing ends well. After a while, he called back and he was again angry. Now developer said, why you're angry now? We just implemented a push-based system. He said, I don't care what you implemented. I don't want to wait 30 minutes over here as well. Why don't you implement a solution? It's a tabular data. Each row should be displayed as soon as it's been evaluated. Why can't you do such an implementation? Developer said, this is a smart solution that you're giving. Let us sit down together, all the devs together, and try to figure out a best solution for that. So now again, the developers sat down together and they thought about how we can implement this solution in a much more smarter way. Because right now the problem is we are passing this function, it's calling it over here, and it's taking 30 minutes. Third-party author said, I have a solution. One developer said inside it that I have a very great solution. He said, the other developer said, what's the solution? Just tell us, because our customer is angry. We have to implement it. So now he said, instead of passing us two functions, pass us three functions. So what three functions? He said, pass us next, complete, and error. So they said, what's next is, he said, it's quite easy. Instead of calling resolve over here, we'll call complete over here. And in between, we will send some data, because as per our calculations, we can even evaluate in 1 minute part of the data. Each part of the data is taking around 1 minute. So 1 minute we resolve one data and we'll call next. So the sequence will go like next, next, next till complete. So once each next, you will getting an event over here. You just get those event and you will start displaying those data. All developers jumped into this solution because it seems really awesome, because it's solving all the problem. So they implemented the solution, and in a way that each next call was displaying this data in the form of tabular. It's showing the data in the form of tables. So each next is displaying this table form data. They implemented the solution, gone to production, and the customer was really happy. He was quite happy with this solution because they don't have to wait for a long time for any of the data. Since this solution was so successful, all the devs said we should say something, and they called this solution observable, RXJS observables. As you can see it over here, it's just a way of passing function and the producer doing something with those functions and calling them out. Like it's calling over here, it's calling over here, and if there is error, it will call error. And consumer who send those functions can listen to those functions and act upon it. That's the push-based system, that's the observables. As you can see how it differentiates from events, how it differentiates from promises, that's, I think, is quite clear up till now. The solution was implemented, the customer was so happy that soon he told other customers and he lined up with more customers. All that said, we want the same solution that you implemented for this guy, we want the same solution. Now the devs were really happy, but they have a bit of a problem in hand. The problem was quite simple, but as you can see that they want all of the same solution. The third party author said, wait. If I keep on implementing this same way, we have to compute, and I don't want to waste my compute power because we are on cloud. It's going to cost us some money to do all the time. We can be a bit smarter for this. A normal way of doing this is to just have a variable over here. For example, we have a var variable cache data, and once the compute is completed, we put this variable cache data equals to result, and that way we could send the cache data back to the consumers, to the consumer, instead of each time computing it out. But in this scenario, it's a bit complicated. As you can see, we can't do it in this way because each next needs to be cached. So they can create a dictionary and cache those dictionary next, and they can return it out to solve this issue. So they said, okay, we have a solution for that. The developers over here said we had got a solution. They built some operators around it, and they call something subject. And that is what subject is doing, basically behavior subject and these things, that it's something outside the scope of the actual function and doing these operations. So they call this solution subject. So they implemented this subject-based solution, and every person who customer asks for data, the same way it gets the data. When he asks for data, he don't have to do the processing again. He gets the data quite quickly because it's the same inputs he's supplying. So he gets the data quite faster. He's way more happier. And then once he asks for the same data is displayed to him. And this chart is displayed 3 times. So 3 times, and first time is the one only time it gets computed. For second and third time, it was just a cache data. And this way of doing things, taking things out and caching them out for future use, that way is called hot stream. So if you ever heard about developers talking that it's a hot observable or a cold observable, the hot just means, the hot keyword just means a way so that once we call an observable, it doesn't compute. It just returns the cached value if it's already done. If it's not done, it computes. If it's already done, it's going to return the cache data. So that's what hot stream means. Opposite to the hot keyword, there is a cold keyword. The cold is the first caller. The cold is the earlier solution we discussed. The older way we just discussed, the next complete and without caching the data, that is the cold stream. So now you get the concept about hot stream and cold stream. The stream is also a bit like, I feel like it's been used a lot but not explained. It's just the next calling over here. Once the next is called, that becomes a stream. How it's that? So you might have seen a marble diagram like this one. and you may see balls over here, balls over here, balls over here, and you may see some line over here. What does that means? It just means each ball represent a next call, next call, next call, and this line represents a complete call. So you see the marble diagram, the way of representing, it's just the way it is. So now I think you will get a better idea what marble diagrams as well, what they really are. So now let's, with this, all this information and this story in your mind, let us try to understand what they are trying to explain. So now I think there is no need to explain pull and push based system, as you completely understood this concept. Now they are trying to explain observables. Let us understand this. With that story in your mind, I think it will be quite clear. Let's see how. Now, there is a creation part and there is a consuming part. You can see the emission is happening over here. The next one, next two, next three. So quickly you will get this is the producer. And quickly you will get this is the consumer. So now how I'm saying it's producer, as you can see, it's emitting the value, it's producing the value. So that's the producer part of it. And over here it's consuming, logging it out. It's the console logging it out is the consumer part of it. Now you see this syntax a lot. It's JavaScript way of passing functions. So what you can see it over here, it's the starting from here to here. It's just nothing but an object. Instead of passing three functions as is, we are passing them in a form of next, error, complete. And once we are passing these functions, right now the implementation is just whenever somebody calls them, just console logs them. Whenever somebody passes them, so it's a JavaScript way of passing functions with actual implementation inside it. The implementation, and whenever who calls next, the console log happens. Error, console log happens. Complete, console log happens. So this is the object. We are passing it in a function called subscribe. So once we pass, the consumer is passing, as we discussed in the story as well. The consumer is now passing the functions, and the way producer is receiving those functions is in the form of this object. What's that object is? Right now it's subscriber. Now we know that in between there is some magical things happening as well in between. Once this consumer is passing to producer, there are some proxy sitting in between and doing a lot of things in between, but let us forget about them. Let us understand in the most simplest way. So now once he receives, obviously it's an object with three functions inside it, and you can see there is an object and it's got next, 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 complete. Now let us go through this thing. Once this next is called, what this function should do, the implementation is quite simple, console log. So that's why we see before we begin, we just have this function call. It starts with here. Now the important point, the really important point is the subscribe point. This point, that is the part of start of execution happening. So till this point, the producer is just defining what it is. At this point, before this point, producer just defined what observable is, and it's set into this constant observable. Now after he called the subscribe and passed this object, at this point execution starts happening. So at this point, the starting point of execution is starting from the consumer. The consumer says dot subscribe, and it starts executing past this object, and it goes through, this is the object, it goes through over here, and once he calls next, what should happen? This one is executed. Once this one is called, as soon as the next one is called, we receive this one. Now you get it? This line is already executed. This one starts executing after, at the time of subscribe. You get the 1. Once the 2 is called, you receive the 2. Once the 3 is called, you receive the 3 in the console log. That's quite clear. The thing which is not that clear is what this set timeout is and how it's working. Now, if you know a little bit about JavaScript, set timeout is a way of scheduling things. So JavaScript single threaded, it executes in a linear way, but set timeout makes things async. How? It just scheduled it for a future time. At which future time? 1000 milliseconds. So after 1000 milliseconds, it's gonna do basically all browsers have implemented a scheduling mechanism for that, such that once set timeout is called, Web API register it in a schedule and say, okay, after 1000 milliseconds, we're gonna call this function. 1000 milliseconds pass by, this function gets called in. This function starts executing. Next, 4 is called. But before that is after 1000 milliseconds. So before even that, this line hits because set timeout appears, and set timeout says it's for future execution, so it start executing just after subscribe is then called. Now it's waiting till 1000 seconds. Now 1000 milliseconds pass by. As soon as 1000 milliseconds pass by, this function gets invoked. Now next 4 is called. You can see that. Then complete is called, and complete time we are just logging console log done. So that is done. So the important point over here, two important parts are there. First, subscribe means the starting point of execution. That's the one important point. The second important point, are the observables sync or async? As you can see, the first 3 dots, they were sync. Sync means as soon as they are called, the execution happens as immediately. Next call, immediately this function get invoked and called. In between, we had some set timeout. The set timeout makes it schedule it for future execution. So now you understood observable can support synchronous data as well as asynchronous data. So this is the synchronous part, this is the asynchronous part. So observable are designed in a smart way that they support both ways of implementation. But the question comes, if we create an observable, are we getting data async or sync? As you can see, by default, observables are always sync unless you use set timeout kind of thing, or async schedulers, or an operator like delay, or these sort of, there are many other operators which can make you go through set timeout or set interval type of functionality. Only then they becomes async. By default, observable are synchronous. So let us proceed further. Now over here, they are explaining again pull versus push mechanism, and I think you get a better understanding about push and pull. After that story, I think it should be clear. Observables as generalization of function. Now they are trying to explain, because people get confused around observables a lot. They think there's some magical thing happening in between. But now after that story, I'm sure that you are a lot more clear that it's just a way of passing those functions around. So what they're saying, we create a function. What they're trying to explain is this is the producer part, and we can call it out the same way. That is the producer part, and we can call it out. That's quite simple. So you don't have to get confused why we are creating this one over here. We don't get confused once the function exists like this and we call it out. I'll quickly go through the creating observable. We know how to create, as we have seen already. Subscribing to observable, we have seen already. This is the really important point. .subscribe, that's the execution starting point. Depending how it's implemented, how the producer has implemented. If the producer is a hot stream, as we have already discussed, hot stream means something is being cached. So the subscribe will call the producer will quickly return the result without executing it. If it's a cold stream, it means if it's a cold stream, then it will go through this initial solution, it will start executing, and for every call it starts executing. It's really important to understand these concepts, because most of the time you will be using observables in HTTP calls. So if you're using Angular, you will be using HTTP client, which will be internally using observables, and they are cold. So once that cold means you have to make them hot. They are operators to do those, make this cold stream to hot stream. But the important point, if you don't understand why I'm calling every time I'm calling .subscribe, .subscribe, so I have 3 .subscribe calls, and 3 times it's making the database call or our REST API or whatever call they are making, it's making 3 times. So you will get confused why it's calling 3 times. It's because you have a cold stream. You have to make it hot. So once you make it hot, it will call it 1 time, and for the rest of the 2 times, it will use the cache value and returns the data to producer, which will be basically get to the consumer. Let's proceed further. Now, executing observables, we have discussed that. Disposing an observable, that's an important topic. It's really important. Why it's really important to dispose an observable. Have you ever seen and discussed about .unsubscribe? I feel most of the people who use, or devs who use the observable, they always get this, that we have to unsubscribe. Why we have to unsubscribe? That's really important question. If you know about JavaScript functions, you declare them, you have some function definition, you call it out like that. Now, each JavaScript function is a lexical scope. Internally, JavaScript maintains a lexical scope for this, and a function within a function. So if there is another function, let's call this as a parent function, and inside it there is another function. That's called closure. Function containing another function. The important point is JavaScript maintains lexical scope of this one as well. So inside this lexical scope, there is another inner lexical scope. Why I'm explaining these things? Because JavaScript have a garbage collection. It means we never clean things out. It cleans them automatically. How it cleans them? As a basic thing, it just checks the reference. If the reference exists, it won't clean. It won't garbage collect them. If the reference doesn't exist, it will then throw them to a bin. So this is a very simple concept, that if the reference exists, don't clean them. If reference doesn't exist, clean them out. What does that mean in our scenario? Because if we have declaring, because observables, you see that they're just passing of functions. So if you're passing to producer these 3 functions inside it, so you pass these 3 functions to the producer, and producer is doing all the work and calling those functions out. Imagine if you haven't cleaned those functions out, you pass those to the producer. Now JavaScript says there is a reference existing to it. Now even the consumer doesn't exist. What does that mean? So for example, you have a component, you are in Angular. So for example, in Angular project, you have a component, parent component, and you have a child component. The parent component is calling the child component, and inside the child component you have ng on init, simple things, and inside that ng on init you have some .subscribes, like observable.subscribe many times inside it. Now if you don't destroy them using take until way of doing things, there is different patterns to destroy. Calling .unsubscribe, you can use take until way of doing things, ng on destroy. There are certain decorators you can make to make things undestroy as well. What I'm trying to tell you, that destroying is really important regardless how you do that. So for example, you declare this component, JavaScript have a reference of this one, JavaScript have a reference of this one, JavaScript have a reference of this one, JavaScript have a reference of passed down 3 functions which you pass down at subscribe over here and here as well. Now at the time, for example, you have some tabs, you click on this tab, this components exist in this tab, so they should be destroyed, right? So we are passing these 3 functions, JavaScript is maintaining those reference. If we haven't destroyed this functions, guess what? Even though we switch the tab to this one now, this should be destroyed. So this should be destroyed, this should be destroyed, this should be destroyed, and this should be destroyed. But internally, you can use it and verify it using console log that it will be still calling these functions. This subscribe will be inside it, these 3 functions. The producer will keep on calling them, and this will keep on invoking. So what it means? A memory leak, a quite severe memory leak. So just remember, disposing observable is really important. So I hope after going through this video, you have now a way better understanding of observables. And if you like this video, please share and subscribe so that I can make more videos and go through some complex topic and dive deep into those topics as well. Thank you. Thank you for watching.